All right, welcome back. We've got another one. Good to have you all here. Let's start with a joke. What do you call fake pasta? An impasta. Impasta, because it's fake. Impasta. Okay, let's start. Okay, so now today, this is probably the main concept here that we're trying to get. We're going to learn how to differentiate trig functions. Okay, now straight off the bat, we no longer think in degrees. Okay, the moment that we start thinking about calculus, we need to think about radians. That's why we taught you about radians. That's why degrees doesn't cut it anymore. Okay, we have to think in radians. Now, what we're going to talk about is in class, we'll go through it together, but for everyone out there, let's just take a look at some of the rules here. Okay, so let's just look at the basic level. So if y equals the sine x, your differentiated version is just going to be cos x. If you've got y equals cos x, your differentiation is going to be negative sine x. And if you've got y equals tan x, and of course, tan being the black sheep, your derivative becomes sec squared x. Okay, now I'm not going to go and explain these. I think there's a million other people out there who will do it better. Let me just go through this. Now, that's what you are given, and that's the most basic kind of form of this. Now, what you get on your reference sheet is a little bit more intense. Okay, now what's nice about this is for any function that you get, it works. So if you have sine of fx, your dy dx is very, very similar to your chain rule. So your derivative comes out the front, and then your sine becomes cosine, and then your function remains the same. Okay, same thing with cos of fx. Now, when we differentiated cos, we get negative sine, but this time we're just going to bring a derivative of our function out the front, and then we're going to get sine of fx. And for our last one here, you guessed it, we're going to have an f dash x, but instead of sine or cosine, we're going to have sec squared of our function. Okay, those are your derivatives. Now, let's take a look at how these might play out in the questions. Any question that they do in terms of derivatives. Now, when it gets to like product and chain, you guys, and quotient, you guys are going to have to remember how to do that yourselves. I'm not going to teach it in this lesson, but let's just have a go at differentiating and using the mechanics of differentiating here. Okay, so for this first one, we've got 2 sine x. Now I'm looking here, this is just a singular x. Okay, there's nothing special about it. That means it's just going to become 2, and sine is going to differentiate to cos x, right? Because there's nothing fancy about this. Okay, so because it's just a singular x, I can deal with it. Now for this one here, for b, our y dash. Now the way I think about it is, remember, it becomes, it should be f dash x negative, or negative f dash x sine 4x, or sine of our function. Okay, that's what it should be. Now that means our function, our fx in this case, is whatever's in the bracket. So in this case, our 4x. So that means our f dash x just becomes 4. So that means I guess our differentiation comes out to the front. And let's work at this bit by bit. So first, the differentiation, our f dash x comes to the front, or our negative times our derivative, which is going to be 4. I'm still going to have that negative 3 from before, because that's a constant. Cos becomes sine. And then our bracket or our function stays the same. Right, so cleaning that up a little bit, I'm left with positive 12 sine 4x. Okay, so that there becomes our derivative. Okay, now very, very similarly here, let's do this. Our function that we have inside our bracket of tan is going to be x on 2. So that means our f dash x is actually going to become a half. Okay, because it's the same thing as saying half x, and when you derive it, in this case, the x will disappear, leaving us with half. Now that we've kind of seen that kind of in play, we can go ahead and derive it. So first things first, our f dash comes out the front, which is going to be half. We still have that 5 because it's a constant, that thing doesn't change. And then tan will turn into sec squared. And then x on 2, we keep our function the same within the brackets. So just to clean it up a little bit, this will leave us with 5 on 2, sec squared, x on 2. Okay, so that's it. That's how you differentiate sine, cos, and tan, and functions of sine, cos, and tan. And hopefully that helps out. I'll catch you guys in the next lesson. See ya.